Alrighty, we are wrapping up our study of how to solve quadratics. We started out the chapter by talking about solving by graphing. There's kind of multiple ways to do that, but the best way is to get one side equals 0 and then your x-intercepts are your solutions. We solve by factoring, which is nice and quick and easy, but it has to be factorable. Then we talked about solving by square rooting, but that was only good when there was no b term or it was in vertex form. Then we talked about solving by completing the square, which always works. But the only issue is there are many places to mess up. And then we just learned how to solve by the quadratic formula, which is basically the same exact thing as completing the square, except for someone did it with ax squared plus bx plus c equals 0. And the formula basically takes care of everything you would have done if you would have completed the square. I like that method. I just got really good at it, and it always works, which is nice. Now we're going to wrap that information together with other stuff from the chapter before this into this lesson. This is applications. So this original problem right here is saying that the height of an object is determined by the original height, the original upward velocity, and the number of seconds since it was launched. We came up with this formula. It was like negative 16 x squared plus original velocity x plus the original height. It says match the important parts of the graph with the corresponding desired informations. So the y-intercept is going to be the original height. The axis of symmetry is the time when it gets to the highest point. The vertex is going to be the max height. It also has the time at the max height, which is kind of nice. And your zeros are going to be the time when the object hits the ground. Now, technically you could find that out by graphing, by using solving by factoring if possible, solving by square rooting. The two that it will always work is completing the square and quadratic formula. Those work when the answers are nice, when they're not nice, when they're imaginary answers. So let's go ahead and move on here. The applications. The function that describes the height of an object, h, after x seconds is modeled by the equation h of x equals negative 16x squared plus 250x plus 20, where the original height is 20, the original upward velocity is 250 feet per second. Use a calculation, not graph-based approach to determine the following desired information. So it says, when will the object be at its highest point? If I did not say that you had to use a computation-based way of doing this, you could just graph it in Desmos, click on the highest point, and it would say it was at its highest point at 7.8125 seconds. Now, what you needed to do was use the start thinking part that says use the axis of symmetry to find out when it's at its highest point. And the axis of symmetry is x equals negative b over 2a. So it'd be negative 250 over 2 times negative 16, which spits out 7.8125 seconds. The next one says, what is that highest point? Normally, you would have Desmos. You click on the highest point, it tells you the highest point. But this is supposed to be a calculation-based approach. So you would substitute in that time, saying, I know it's at its highest point at 7.8125 seconds. So let's put that in there. You could have either written it out as a fraction, as I did, or just writing out 7.8125 seconds. And when you punch your numbers, pop that in your calculator nicely, you end up getting 996.5625 feet. The next says, when will the object hit the ground? Now, once again, if you had Desmos, you would just click on the x-intercepts, and it would tell you when it hits the ground. In this case, though, I asked you to do a computation-based way. So we know we can solve by square rooting, by factoring, by completing the square, or by square rooting. The thing here is I know that the answers are most likely not going to be pretty answers. It's probably going to hit the ground at like 5.237, whatever it is, but it's not going to be pretty answers, which tells me I'm probably not going to be able to solve by factoring. And what I'm going to have to do is either complete the square or the quadratic formula. So what I decided was to solve using the quadratic formula. So right here it says negative 16x squared plus 250x plus 20. That should say equals 0 because we're trying to figure out when it hits the ground. Equals 0. And since it's in that form, we can already see your a, b, and c value, negative 16, 250, and 20. And you just pop them into your quad formula. I decided to put 250 squared minus 4 in parentheses 4 times negative 16 times 20, enter, and that gave me my 63,780. So I put that in the calculator to find out what was going to be under the radical, but I didn't try to put the whole thing in the calculator. That'd be too crazy. Then I put negative 250 plus red, 63,780, enter, divide by negative 32, and I put negative 250 minus the square root of 63,780. Enter, divide by negative 32. And you get two answers. One is negative 0.08 seconds, and that is technically an extraneous solution. So I should have gone over and X'd that out. That doesn't make any sense for the problem. We did everything right, but it just doesn't make sense to go into the past. And the reason why it has this is because it's asking when it hits the ground, and it starts at 20 feet high. So the only way it could hit the ground, if you're thinking the parabola, would be into the past. So that one is an extraneous solution. It doesn't make sense for the problem. Then when you put the other one in, negative 250 minus square root of 63,780, enter, divide by negative 32, you get an answer of 15.7 seconds. So that is the only time it'll hit the ground. It was above the ground when it was launched, so it only hits the ground once. If it started at ground level, there would be 2 times where it hit the ground. Now here's another application. This says Chase Field in Phoenix has an open roof. They're able to open it or close it. The height of the building is 240 feet tall. I actually looked that up. A model rocket is shown, or is supposed to say shot from the field at an initial height of 30 feet high and an initial upward velocity of 180 feet per second. The function that models this is negative 16x squared plus 180x plus 30. Use a calculation-based approach to answer the following, not a Desmos graphing approach. So it says you're sitting outside the field and you see the rocket fly out of the top and then back in. And the question is, how long did you see the rocket? Remember that the height of the building is 240 feet high. So really this is asking, when did you originally see it? When did it get higher, start getting higher than 240 feet? When did it hit 240 feet? And then you would see it while it was above that, and then it would be coming back down until it hit 240 feet again. You can see my little drawing. So you're basically asking yourself, when will the height be at 240 feet? And you're going to get 2 different times. And let's say one time was 1 second, the other was 5 seconds, then it would be above for 4 seconds. So the first thing you want to do is solve this to find out when is it going to be at 240 feet. If you could use Desmos, you would just solve by graphing, either once you set equal to 0, or just look when the horizontal line is at 240 and subtract those numbers. But we are doing a calculation-based approach. And if I'm going to be using the quadratic formula, which I really like, one side has to equal 0. Once you do that, you have your A value of negative 16, your B value of 180, and your C value of negative 210. So when you put all that into your quadratic formula, you simplify under the radical and you do the adding and subtracting version, you end up getting 1.3 seconds and 9.9 seconds. So it's shot up and you start seeing it at 1.3 seconds, you're seeing it, it's above the building, and then it enters the building again at 9.9 seconds. So when you subtract those, you saw it for 8.6 seconds. Okay, hopefully that made sense. The next one says, how high is the rocket at 6 seconds? Is it on its way up or down? So remember from a previous section, what we learned is you can just substitute in values to see what the input gets as an output. So the input is 6 seconds, and we want to know what the output is. When you substitute in 6 and use your calculator, it spits out a 534. That would be the output. So 6 would be part of the domain, and 534 would be part of the range, and that is the input-output combination. The next question is it on its way up or down? This is a little tricky. You know it'll be on its way up until it gets to its highest point, and then it'll start coming down. It's at its highest point at the axis of symmetry. So when we calculate the axis of symmetry here, it is at 5.625 seconds. It'll be going up until then, and then it'll start coming down until it hits the ground. So since we're at 6 seconds, it was going up till 5.6 seconds, and then at 6 seconds, it's back on its way down. So that would be on its way down. Next one, the application. It says an object is shot up with initial upward velocity of 160 feet per second. It reaches a height of 340 feet after 2.5 seconds. What was the original height? So when you get something like this, you write out the equation or the formula and you put everything you have in and hope you only have one missing part. In this case, you can see the equation is negative 16t squared plus 160t plus h of 0. H of 0 just means original height, height at time 0. When you substitute in the 340 for the height and the 2.5 for the number of seconds, you only have one piece missing. That simplifies on the right to 300, the left is 340, and when you subtract, you get 40. If you wanted to check your answer, you could always write the equation again with h of 0 being 40. Go ahead and pop in 2.5 and make sure you get 340. All right, hopefully that made sense. This is applications. It shows when you would need to use the quad formula versus axis of symmetry versus vertex for a problem like this. Let's take a look at the homework. The homework says the function that describes the height of an object h, height of the object h after x seconds is modeled by the equation h of x equals negative 16x squared plus 320x plus 50, where 50 is the original height, 320 is the feet per second upwards. Do not use a graph-based approach. It says, when will it be at its highest point? We know that's the axis of symmetry. You do negative b over 2a, and you end up getting 10 seconds. It takes 10 seconds to get to its highest point. Next, what is that highest point? Well, this is nice. You just say that at 10 seconds, how high is it? You just pop it into the formula, and it says it is 1,650 feet high. You could always double check by using Desmos as well, but I wanted you to do a calculation-based approach. The next one says, when does it hit the ground? So you're basically saying, when does the height equal 0? So I really should have written this out as negative 16x squared plus 320x plus 50 equals 0. And you can pick your a, b, and c values, which you see I got negative 16, 320, and 50. Pop it into the quadratic formula, simplify under the radical, do it once with adding, once with subtracting, and you get two answers. Once again, that first answer makes no sense. It is extraneous, meaning you did everything right, it just doesn't make sense for the problem. And the reason why is because it is being shot from over a ground level of 0. It's higher than that. So the only way to get to 0 before that is going into the negatives, which makes no sense. When does it hit the ground? At 20.16 seconds. Hopefully that makes sense. Next, when will the object be 100 feet high? You're basically saying, when will negative 16x squared plus 320x plus 50 equal 100? If you were solving by graphing, you could either set it equal to 0 and then look at the x-intercepts, or you could just see where this thing is at 100 feet high. When you do it using the quad formula, you have to get one side equal to 0, so you can get your a, b, and c value. And when you substitute it in, you get 0.16 seconds and 19.8 seconds. It'll be at 100 feet high on its way up, and it'll be at 100 feet high on its way down. Okay. You can see that it was 100 feet high very close to when it hits the ground, because it hits the ground at 20.16 seconds, and at 19.8 it is already almost at the ground. An object is shot up with a certain upward velocity, is shot from ground level now, not at some random level. It reaches its highest point at 483 feet after 3.1 seconds. When does it hit the ground? When you look at a parabola that starts at 0, 0, what you find is that the axis of symmetry will cut it in half, which means the amount of time it took to get to its highest point will be exactly the amount of time for it to get back down. So if it took 3.1 seconds to get to its highest, it's another 3.1 seconds to come down, and it'll be 6.2 total. Now, the other one is actually symmetric as well, but the way it works is it's symmetric about getting back to the height it started from. So if you find out how long it takes to get to its highest point, it'll take that same exact amount of time to get back to where it was shot from, which might not be at a starting point of 0. It might be at a different starting point. And then it takes some more time. Let's say it was shot from 100 feet high. The amount of time to get to its highest point will be exactly the amount of time to get back to 100 feet high where it was shot from, but then you have some extra time for it to get all the way to the ground. I don't know why that zoomed in. Let's zoom it back out. Okay, an object is shot in the air with an upward velocity of 120, original height of 40. How high is the object after 3.2 seconds? Will it be on its way up or down? So it's pretty easy to find out how high it'll be. You just have to write out the equation, negative 16x squared plus 120x plus 20, and substitute in 3.2. After you get that, you are going to find out that it's 260.16 feet. Now, to find out if it's on its way up or down, you have to find out when is it at its highest point. So it's at 3.75 seconds is the axis of symmetry. So it's going up until it gets there, and then it comes back down. Since 3.2 is less than that, it's going to still be on its way up. Now, lastly, on number 4, the equation that describes the height of an object h after x seconds in vertex form is as follows. What is the max height? Well, vertex form is beautiful because it tells you the vertex, and you see the vertex is at 2.2 comma 180. So that means that the height must be 180 feet high. When will it be at that height? Well, the vertex is 2.2 comma 180, so it's at 2.2 seconds. And the next one, what is the original height? Now there's two ways to do this. I think I put a hint on your version, and the hint says what time is it when it starts. That is at time equals 0, so you can substitute in a 0, and that'll give you the original height. The only other way I can think of doing this is doing your foiling, and then multiplying by -16, and then combining with the 180, and you would find out what the y-intercept was when it's in standard form. And that standard form would get you a height of 102.56 as well. All right, hopefully all that made sense. Thanks for watching.